Hey guys, this is Carrie, and this is the answer key to homework number 3. Alright, so we have if ax plus b is equal to cx, determine the value of x in terms of a, b, and c. So similar to a lot of the problems we've been doing as a class, we've got two separate x's in the equation. So we're going to need to figure out how do we go from two separate x's to one x to isolating x. In order to do that, we'll have to move our x terms to the same side, so we can subtract cx on both sides. That gives us ax minus cx equals b. We factor out, wow, that's a typo. Ax minus cx plus b equals 0. All right, now we got our x terms on the same side, but unfortunately we have this extra b also. So we need to move that b to the other side, so that all the terms on this side are x terms. We subtract b from both sides. That gives us ax minus cx equals negative b. Now that both terms on this side are x terms, we can use the greatest common factor. Keyword being common, because they share the x in common, we factor that out. X times a gives us ax. X times negative c gives us negative cx equals negative b. And we divide by a minus c on both sides. This cancels out, giving us x equals negative b over a minus c. What are the two names of the factor methods we've learned so far? GCF, sum, and products. Completely factor each of the following expressions. So it looks like this is going to be a GCF problem, because we don't have that classic three-term setup like we do here. That three-term setup is an indicator of sum and products, but since we don't have it, we'll use GCF. 20 and 14 share only 2 in common. 2 times 10 is 20, a squared minus 7, 2 times negative 7 is negative 14. Notice that we can't factor out any a's because this term didn't have any a's. 27b to the 7th minus 12b to the 5th. 27 and 12 share 3 as a factor. We also have, looking at the b groups, b to the 5th in common, because b to the 5th is hidden within b to the 7th. So that gives us 9, b to the 2nd, because if we factor out 5 of those b's, we're left with 2, minus 4, and we're done. Here we have 18, 45, 63. So even though we have 3 terms, because the leading coefficient is 18 instead of just x squared alone, we have to use GCF. So 18, 45, and 63 are all divisible by 9. That gives us 9 times 2c squared minus 5 times c plus 7. Completely factor each of the following expressions. These ones, GCF is going to fail for. Luckily, we have that new method, sum and product. So the reason why it's called sum and product is all of our factors are constructed by finding numbers that sum to 8 and have a product of 15, the second one. So x times x is x squared. Let's see, two numbers that multiply 15, 3, positive 3, and positive 5. 3 times 5 is 15, 3 plus 5 is 8. For this one, x times x is x squared. 5 times 3 is still 15, but to make negative 8, we need to have negative times negative. Negative times negative is still positive. Negative 5 plus negative 3 is negative 8. All right, let me just get a couple more answers on the page. So we have x plus 5 times x minus 3 here, x minus 5 times x plus 3 here, and the last two I'm going to leave for you. Completely factor each of the following expressions. Whoa! All right, the first one looks pretty straightforward, but those next ones look pretty crazy. Let's see how these work out. So for this one, it looks like a classic sum and product. X times x is x squared. And then we're looking at two numbers that add to 7 and multiply to 12. That is 3 and 4. 3 times 4 is 12. 3 plus 4 is 7. All right, the next one looks really crazy. So you might think, well, this definitely doesn't look like sum and product. Maybe it's GCF. But because the last term has no x's, we can't factor out any x's. So we only have one possibility. It's got to be sum and product, even though it's a little weird looking. So let's see. In the previous problem, x times x gave us x squared. Well, what times itself would give us x to the 10th? Let's see, x to the 5th times x to the 5th. When we multiply these, we add the exponents. That does give us x to the 10th. And let's see if the rest of it works out. So let's pretend that the rest of it is just regular sum and product. Multiplying to 12, it's got to be 3 and 4. Sorry, multiplying to 12 and adding to 7. Let's see, do we need to have an x here, maybe, or an x here? Let's check it by distributing. So I'm going to do a check down below. X to the 5th plus 3 times x to the 5th plus 4. We can check this by distributing. X to the 5th times x to the 5th. We add the exponents, getting 5 plus 5 is 10. We get 4x to the 5th plus 3x to the 5th plus 12. Combining like terms gives us 7x to the 5th plus 12. And notice that this x to the 5th that we put in our solution doesn't just create the x to the 10th, but actually, because both of the other distributions became x to the 5th terms, it also creates this x to the 5th term in the middle. And this exactly matches the starting pattern, so this must be correct. For the next one, we have x to the 6th. Well, in order to make x to the 6th, we need x cubed times x cubed plus 4 plus 3. And let's see. This is going to give us an x to the 6th term. This is going to give us an x cubed term. This is going to give us another x cubed term. And this is going to give us a term without x's. So I've left out a couple of details. This was 3 and this was 4. Because what I really wanted to focus on was this x to the 6th is generated by those x cubes. So that's great. But also these x cubes in the middle combine to make the x cubed in the middle term. And so it's nice to have chosen x cubed here. All right, to see if you really understand this problem process, I'd like you to try to do problem 6 all on your own. So just to be clear, guys, I'm going back to problem 5. I'm going to use a red box, and I'm going to circle up my final answers. I did a lot of work to check things, but the final answers are the factors in these problems. All right, finally, problem 7 is a pretty crazy challenge. But if you really understood problems 5 and 6, problem 7 is very similar. So maybe this is a GCF problem. Well, these two have x's, but this has no x, so they don't have x in common. These two have y, but this one doesn't have y, so they don't have y in common. And even though these two have numbers, 9 and 20 share no factors, and there's no number here. So it's not going to be a number that they share in common. So it looks like GCF is out, which means that sum and product is our only possibility. So even though this looks nothing like a sum and product problem, let's see if our ideas work. Well, what times itself would give us this term? X times x is x squared. Y to the 4th times y to the 4th is y to the 8th. Now we're looking for two numbers that sum to -9 and have a product of 20. Well, 5 and 4 multiplied to 20. If I keep them both negative, then negative times negative will be positive 20, and -5 plus -4 is -9. Let's see if this works out. So this is potentially our final answer. I just want to check to make sure that the middle term works out. So x y to the 4th times x y to the 4th is x squared y to the 8th. This gives us -4 x y to the 4th. This gives us -5 x y to the 4th. And this gives us 20. If you combine these two terms, you get x squared y to the 8th minus 9x y to the 4th plus 20, which exactly matches the original